Python, to me, I call it a very highly expressive programming language because it's human readable, and the syntax in Python is quite easy to comprehend compared to other static languages you have like C++ or C Sharp or Java, because you don't need to learn a lot about how those other programs work. You have to learn a lot about how those programs work before you can apply them to software engineering or to data science or to any other thing you want to do. But Python gives us that flexibility. It's flexible, it's expressive, it's human readable, the syntax is friendly, and you can quickly get your hands dirty with Python and start building projects. Okay, my name is Adetola Abiodun. I'll be taking you on this journey for about 2 hours on Python for data science. I'm the technical lead at DarkTech Solutions here in Nigeria. DarkTech Solutions is a software solution company based in Nigeria, and we offer web development services. We offer utility software services. We build enterprise software. We handle data science projects, and we also organize training and seminar sections for companies and individuals. And our training and development team have come together to develop this particular program for the data science community for free. So I hope you are going to take advantage of this kind gesture from the training and development team, and I think we're going to have fun as time goes by. Feel free to call me Tola. It's fine by me. If you have any questions, just drop it in the chat box and I would be very glad to answer you. Okay, this is the outline for today. We'll be looking at what does a data scientist do, because if we say data science, it means a data scientist is someone that practices data science, as simple as ABC. So why do we have to also learn Python? How do we get to learn Python? How do we start learning Python? What are the useful links and resources to learn Python? And how to use, excuse me please, how to use one of the most important tool in Python known as the Jupyter Notebook. And for today's project, we'll be looking at data cleaning, analysis, and we're going to be generating some beautiful plots and visualizing data in Python using some inbuilt libraries. And I hope we're going to have an exciting time in today's class. Okay, so what does a data scientist do? First, I would want you to see data science from a layman's definition. I love to break complex things down and make it very easy. I don't believe in so much complex documentations and you start getting people confused with very big definitions. But just look at data science from, okay, the scientific study of data. It's just as simple as that. And why are we studying data? We want to extract meaningful information, right, from data that would help us make decisions. Either we want to predict, something from our data, or that would let us make business decisions, organizational decisions, behavioral decisions, depending on your business domain. And data science is interdisciplinary. What I mean by that is it combines a lot of other fields like mathematics, computer science, data analytics, statistics, and all that. Depending on your business domain, like I said earlier, but your knowledge of statistics must be very sound, and probability, descriptive statistics, you must be very sound with, you must have a sound analytical knowledge, okay, for you to practice data science. And like I said earlier, the role of a data scientist actually differs, okay, depending on the company you work with. My background, for instance, is in geophysics. I'm a geophysicist, and I've been applying Python to geophysics for about 2 to 3 years now. Okay, I've been trying to do some QC on well logs, trying to display seismic data, and running algorithms like convolutional neural network, okay, to classify seismic fishes and all that. Okay, so that's just one example of applying data science. For instance, you might be in the pharmaceutical domain. You might be a doctor, and you want to predict, okay, the symptoms that patients have. You want to predict the kind of sickness that a particular patient has based on data that has symptoms of a particular disease. Okay, so that's another example where data science can be applied. So depending on where you work, there's data everywhere, structured, unstructured data. Okay, so it's dependent on your domain and your desired um, result. Okay, so why should we learn Python for data science? Of course, there are a lot of other tools available to practice or to do data science, but 4 years ago, it overtook R. R is another statistical programming tool. It's very common amongst the statisticians. It's used a lot by them. And on Kaggle, Kaggle is a community where data science competitions have been hosted, data science hackathons, okay, and the science competitions 4 years ago, based on statistics, showed that Python was more, preferable and was more used compared to R on that competition. And even 3 years ago, on KD Nugget's annual poll of data scientists most used tools, Python also came first, and 66% of data scientists 2 years ago reported using Python daily. Even me, I myself included, I don't think there's any day I don't, use Python to do one or two things, okay? And it makes it the number one language for analytics professional, because you can just quickly grab a Jupyter notebook, okay, write few lines of code and do a quick QC on your data, okay, because Python is, like I said earlier, is human readable, is human friendly, the syntax is great. You don't have to learn complex documentations before you start doing something, okay, with Python. So how do we learn Python for data science? It's paramount that if you're getting into a new field or an endeavor in life, you first have to learn the fundamentals. It's very, very important. So you have to learn the fundamentals of Python. You kickstart your learning by joining a community. Like I said earlier, there are a lot of communities like Kaggle, KD Nuggets, and a lot of them on you can just Google search, data science communities. There are a lot of them. Slack, you could join Slack. Just hook up with a data community, and you will see a lot of materials being posted in there. And you can also try your hands on the command line interface. What I mean by the CLI here is the Python shell, not the GUI graphical user interface navigator like Anaconda or something. You might just want to practice Python by writing a bit of code or scripts, okay, in the Python shell. It helps you, and it gives you a solid foundation on your Python fundamentals. Secondly, you can practice mini Python projects, like you can just pick up data from a survey and you just analyze it. It could just be a survey of students, okay, boys, girls, I'm sorry, male, female, maybe their heights and their favorite food, and you just want to see if tall people like beans and short people love spaghetti, just for instance, you just want to look at different variation in data correlation. You want to check the mean count of maybe male students, or the mean value of female students. Those are just simple stuffs you can analyze from a survey data. And you might even want to track and analyze your own spending habits. Am I spending too much money on groceries, or I'm spending too much money on transportation, for instance, or maybe on some other miscellaneous expenses, so you might just want to track your own spending habits and get insights from how you live. So the third most important point here to me is to learn Python data science libraries. Is very, very key. We have 4 inbuilt libraries in Python: NumPy, PANDAS, Matplotlib, and scikit-learn. NumPy means numerical Python. It's used more by the mathematicians. It has a lot of, it's useful in numerical analysis, and it has a lot of functions and inbuilt methods in NumPy that makes your life easy when it comes to numerical computations. Pandas, just to make things easy, looks like your Microsoft Excel. Okay, once it's just like an advanced Microsoft Excel suite, and it can handle large number of rows and columns at a particular large number of rows. Your Excel is going to break down. Okay, it's not going to how to put the number of rows and columns you have again, and that makes Pandas a very, very powerful library for data wrangling, data cleaning, and it even helps you visualize data, because it's also built on Matplotlib. Matplotlib is the default data science plotting library, or data plotting library, or visualization library in Python. It's very, very cool. It shows you nice graphical images. And scikit-learn is the machine learning library, the default machine learning library in Python. Okay, it's used for prediction and advanced data science. And fourthly, you might want to lay your hands on how to apply advanced data science techniques, such as regression analysis, classification, k-means, clustering models. Okay, k-means unsupervised learning, and classification models such as your supervised learning or logistic regression. And lastly, you might want to lay your hands on creating an artificial neural network using scikit-learn. Okay, like I said earlier, you might just want to make predictions from a particular data set you have, and so you can allow your neural network, or train your neural network rather, to learn on a test part of your data, on a trained part of your data. Okay, and you can now splice the classification on your test set, and if you are able to get a very good cross-validation score, okay, and you are satisfied with the algorithm used, then you can splice it on the data set that you want to classify or you want to predict from. All right, useful links and resources. Let me change my pointer options to laser pointer. Okay, that's fine. So it's very important for you to read books, and read books. um, you can never die from reading. I usually say that a lot, and the more you read, the more understanding you get about, you know, different concepts. Okay, so read books, read blog posts, and feel free to also look at other people's source code to learn Python. Okay, there are a lot of notebooks flying over the internet on different concepts, a lot of scripts. Okay, you can get it easily on GitHub. Okay, a lot of source codes are being hosted on GitHub. Okay, and one of the one of the amazing books you can get in data science is written by 25 amazing data scientists. That's called the Data Science Handbook. Wow, what do you expect? A book written by 25 data scientists. That's a lot of information, and it's one of my favorite books, and one of the very good books that has helped me personally is Automate the Boring Stuff with Python by AI Sugat. It's a very, very good book with a lot of illustration, no complex documentations. It takes you straight to what you need to know. And also, Jake Vanderplas has a very, very comprehensive book on data science. It's called the Python Data Science Handbook. And if you want to really get your hands dirty into the intricacies of statistical learning, you might want to check out Trevor, Robert, and Jerome. That's also a very, very good book to get you started learning data science. All right. I said earlier that there is a very, very useful tool used by data scientists in Python, and that is called Jupyter Notebook. But first, though, what is a notebook? Okay, I want you to see it from your usual notebook when you were in high school. What do you do with your notebook? You write down your ideas, right? You write down your thoughts, your organized thoughts, your organized ideas. Okay, and the idea of writing down all those thoughts is you can always go back to your notebook, right, and check what you wrote the previous day, for reference. So it means, in other words, a notebook gives you that workflow, right? It gives you that organization. So it organizes your codes and it gives you real-time input, output behavior. And that's why Jupyter notebooks are very, very, very incredibly powerful in data science. It's interactive and it gives you that excellent presentation of data science projects. And we're going to, once we get into coding, we're going to see what a Jupyter notebook looks like. Oh, great. Luckily, Jupyter notebooks are completely free, so we're not paying $1 or some cents for it, not at all. And lastly, we're going to our example analysis for today's webinar is we're going to analyze a Fortune 500 data set. Fortune 500 is a set of companies in the world, or in the US especially, of top companies in different industry sectors in the world. So we are going to be analyzing the data set. We're going to do some data cleaning, some visualization, and we're going to ask ourselves some basic questions and insights we can get from the data set. All right, let's get to business. Okay, so I'm going to go into my Python editor now. Okay, but before I go into my Python editor, I would like to show you the data set we're going to use for today's analysis. That's the Fortune 500 data set. It's actually a CSV file, Okay, it's a CSV file. That's a comma separated value files. Okay, and we have about 5 columns here, but we're going to import this particular data set into Python, and we're going to do a little bit of data analysis on it. All right, these things can be quite funny sometimes. All right, so to get us started, you might want to come to your Windows Start button here, okay, and you search for Anaconda, okay, and click on Anaconda Navigator. Let's just wait for some few seconds for that to boot up. Depending on the speed of your PC or your system, this should take nothing less than 15 seconds to boot up, maximum 10 to 15 seconds. So all right, it's coming up. Okay, and this is how Anaconda Navigator looks like. Okay, this Jupyter notebook we talked about, at first, and you have some other application or development environment that is pre-installed with Anaconda, your console, Jupyter Lab, Notebook, and Spider by default, and Qt console, I think by default is pre-installed with Anaconda Navigator. For the R programmers, there's an R Studio if you are interested in programming in R, okay, and Orange is used for data mining, okay, and GlueV is for multidimensional data visualization. For people that write codes using VS Code developed by Microsoft, you might want to install the environment. But for today's lecture, we are going to be using Jupyter Lab. I prefer Jupyter Lab to Jupyter Notebooks because it's more extensive. The GUI is more reproducible, it's easier to navigate, and it's still based on the Jupyter Notebook architecture. Okay, so there's really no difference, but this is just a bit more extensive than Jupyter Notebooks, and both of them are actually web-based. Okay, they run by default on your browser on the local host. Okay, so let's just launch Jupyter Lab and let's see how that comes up. So it's booting. Okay, that's perfect. Just going to take a few seconds. Okay, all right, and now this is how Jupyter Lab looks like. The interface of Jupyter Lab, you have a path to the current directory that you are in. This is the current directory I'm in. Okay, and on this tab, the name of the tab, I'm on a launcher tab because I've not opened any Python 3 or any terminal tab here. Okay, so I would first would like to change my directory here because I have a default directory I've been working on here. Okay, so you might not have this same directory or folder on your system. So I've created all these. I've been working on some exercises for a while now. Okay, so I would simply go into notebooks. Okay, and I will create a new notebook. For you to create a new notebook, you just have to click on under the notebook tab here. You can click on Python 3, or you come to File and New Notebook. Okay, but we can just easily click here, Python 3, and you will see on this tab here we already have our notebook has been created. And if you hover on this tab, you can quickly have details of your notebook, of the file rather, your notebook. The name of our file is untitled.ipython notebook, that's IPYNB. You can see the path to your file, okay? And last saved was just 10:52, and the last checkpoint means because Jupyter Notebooks saves automatically, okay? Because sometimes you might be working and you might forget to save your work, so you always have a last checkpoint that is auto saved by Python or by Jupyter Notebook for you. So the first thing we're going to do is to rename our notebooks, and we can do that by just right clicking on this tab and say rename notebook. So let's just call this notebook Python for data science. Okay, and I'll click on rename, and you can see that my notebook has been renamed to Python for data science.ipython notebooks. Okay, and let's just quickly check the menu bar up here. Okay, to if you click on file, okay, like I said, you might just want to create a new console app or a notebook or a terminal, okay, and you might want to close a tab, close and shut down notebook. You might want to reload your notebook from a disk. Sorry for the background noise. There's a lot of construction going on around here, so sorry for the background noise and the distraction. You might want to export your notebook as PDF file, a Markdown file, or HTML file for the web developers. And if we come to the edit tab, it's just all about working on the interface and manipulating input and output. You might want to cut your cells, copy cells, paste cells. You might want to clear your output. You might want to undo or redo a cell operation. Okay, and under the view tab, if we click on show left bar, the left bar disappears. You can easily just still do Ctrl B and Ctrl B. Okay, and you might want to remove the status bar. You might also want to show line numbers, okay, and here in your editors you are going to have line numbers. It's always good to I prefer using line numbers too, so that once you the Python interpreter throws you an error, because it's going to tell you the line in which you have that particular error, so it's easy for you to go back to that line and trace the error. So it's advisable for you to always have line numbers in your editor. So on the run tab, you have run selected cells. You might want to run cells, selected cells, and insert a new cell below. Okay, you might want to run that particular cell and don't advance means you don't want to go to the next cell, stay on the current cell, right? And on the kernel, you might want to interrupt your kernel. That's the engine room of your Jupyter notebooks, that is the connection with the Python kernel itself. Okay, if you shut down your kernel, your codes won't run. Okay, and under tabs, you might want to activate various tabs you've opened before, maybe the next tab or previous tab. If I have a lot of tabs open here, okay, we might just want to click on the next tab by just clicking on activate next tab. Another settings has to do with the general settings you have in your Jupyter notebooks. You might want to change the theme of your notebook to dark or light. I prefer the light version for Jupyter notebooks. You might just in your spare time want to play around all these options here, to get a feel on how your Jupyter notebooks work. Okay, to get us started, okay, let's just quickly look at the tools we have here. Okay, on my left hand, there's a save icon here, and here, this plus sign is if you want to insert a new cell. Okay, I can keep inserting, new cells, and if I just want to delete this particular cell, I can just simply press D twice, okay, D twice, and if I want to insert, I can come back and press the plus icon, okay, and you can still simply right click and click on delete cells. Okay, it's just all the same. This is if you want to cut the content in the cells, you want to copy a cell, paste a cell, you want to run the code in selected cells and advanced, you want to interrupt the kernel, okay, for the stop sign, and this is for you to restart the kernel if you previously interrupted the kernel, and this is I think for you to advance or something, to play your code advanced. And here I would quickly want to explain what these three items are here. By default, if you write any statement, for instance, let me say, welcome to the Python for Data Science Masterclass. Okay, by default, anything you write in the cell, Python sees it as a code block, okay, like as a code, okay, because here we have selected that this cell, every content in this cell should be seen as a code, and you can already see Python highlighting the 4 keyword here. This keyword, these are called keywords in Python. They are reserved words. So there are a lot of reserved words in Python. You can't use reserved words as variable names, okay? And you can't use them especially in expressions, okay? So they are reserved words. You can't use them especially as variables or variable names, okay? So, but if I change this particular code block into a markdown file, you can see this keyword for, it's no more highlighted in green. Okay, so Python is not going to treat this as a code. Okay, it's just going to see it as maybe a title or a heading. Okay, and if we run this particular code block, we click on run, you see it becomes a markdown file. Okay, and you see that by default it jumps to the next cell, right? By default it jumps to the next cell, and the next cell by default is a code block. Okay, it's code. Okay, what if we want to I double clicked here, okay, just to go back to this cell. What if we like to make this a header, right, like an H1 header? It's simple. We'll just put 2 hash signs in front of our text with space. You see the text is highlighted in blue. Now the color of our text becomes blue. Okay, and alternatively, instead of coming to click on run here, we can just do shift enter on your keyboard. Okay, and this, you see the text is now, boom, bigger than the text we have earlier. Okay, and to start up today's analysis, I would quickly want to lay some foundation on data structures in Python. This is just a 2 hours class, so we're not going to go in depth into data structures in Python fully, but I just want to lay a foundation because I'm going to be using a lot of these concepts in in the whole coding class today. So the first thing I would want you to understand are the data types, rather the data types in Python. First, this is known as a comment in Python. If you just want to write some random text, just put an hash before your statement. Okay, so the Python interpreter is not going to run this as a code. It's just going to bypass it. Okay, all right. The first we're going to look at are call strings. Okay, and this is how you write strings in Python. Okay, a string can be, let's name a variable, let's say my name. And to write strings in Python, you have to come with quotes. Okay, you have to wrap them in quotes. Okay, so I can say my name is Tola. Okay, so my name is Tola is a string. Okay, and the value of this string is passed into the variable my name, my underscore name. As simple. Okay, so these are known as strings in Python. So another quick data type is integer, or known as int. Integers are simple. We can just pass a value. Let's say x is equals to 2. Okay, 2 here is an integer. And there's another numeric data type in Python known as floats. Okay, example of floats is y equals to 2.3. Okay, floating point numbers are also known as decimal numbers with decimal places. Okay, numbers or decimal numbers. Okay, let's just make it simple. Okay, numbers with decimals. Okay, that has decimal places. Okay, this can be 2.34, anything. Okay, and another quick one we are going to be using, but I don't think we're going to be using that today, but just for sake of knowing, they are called booleans. Okay, boolean can either be, let's say, is boy can equals to true. Okay, is girl can be false. Okay, so boolean expressions in Python can just be true or false, and in logic we know true to be 1 and false to be 0, right? So true, which is 1, or false, which is 0. Okay, so these 3 or 4 data types in Python are very, very important, and even in programming you see them all around. So I just quickly want to lay a quick foundation on showing you the data types we have in Python, and we're going to be using them a lot in today's analysis. And worthy of note is for you to know that in Python, this is not an equal to sign. It is called an assignment operator. Okay, so an assignment operator. So equal to sign is an assignment operator, and equal to sign takes a double equal to. Okay, a double equal to means you are trying to compare if a particular value is equal to another. Okay, but just one equal to sign, it's you are assigning a value to a variable, like what we did here. We assigned the value, the string value, my name is Tola, into my underscore name variable. And everything in Python is seen as an object, lest I forget. Python is an object-oriented programming language, okay, and strings are actually objects, okay, and strings are array of characters, okay. These are all characters: M, Y, N, A, M, E, T, and other characters you have. So strings are arrays of, characters, okay, and they are actually objects in Python, okay. So to show you the difference between an assignment operator and trying to compare two values, let's go to this next cell and say, let's say z equals to maybe 4.5, okay, and let's say a equals to 3, okay, and let us check for equality and say print a equals to z, and I press shift enter. You see I have an output here telling me false, because the output of comparing two variables, the values in two variables, is going to return a boolean, okay. It's going to return a boolean value which is false. That is, the value of a is 3, right, and the value of z is 4.5, and we know that logically 3 is not equals to 4.5, okay. So this is, you are actually checking for equality, okay. That's when you have double assignment operator, but this is just an assignment operator. We are assigning this value 4.5 to this variable z, okay. I think that is clear enough. So to start today's business, to go to main business of the day, we are going to first import some libraries in Python so we can bring in our Fortune 500 data set, like I said earlier, and run some analysis on it. And one of the first libraries we'll import is pandas. By convention, we import pandas as PD, okay, and we might just want to check the version of pandas we are using. Is very important. So we can say print pandas version, let's say print, let's make it more exciting, print my pandas version is in comma pandas dot dunder version dunder. The dunder sign is a double underscore, okay. So this double underscore, this is not a single underscore, so note as double underscore. So I can just simply press shift enter, okay, and you can see I have an output. My pandas version is pandas 1.1.3, okay, and another stuff we want to do right now is to import our Fortune 500 data set, okay, and we can declare a variable called df, okay. It's just conventional, and we can say data frame equals to pandas. This is an inbuilt method in pandas, pd.read underscore csv, okay, and we can pass the path to our file, okay. Let me first check where I have my file. My file is under data, okay. The data set is under a folder named data here on my system. Your directory might actually be different from my own directory, okay. So you have to know the particular path or the directory in which your data lies, okay. And here my Fortune 500 data set is in my 2020 pandas tutorial underscore notes / data folder. Okay, so it means I just have to move 2 folders up. I can do that by pressing 2 dots, okay, slash data and slash function 500.csv. Okay, and I press shift enter. There was no error. It means I've successfully import my data set and I've passed it into the variable data frame. So to display our data frame, I can just simply write df and I run shift enter, and boom, this is pandas. The same CSV file we have, pandas has converted it into what is called a pandas data frame. So this is known as a pandas data frame, and below our pandas data frame we can see we have 25,500 rows and 5 columns. Okay, that's quite a large number of rows to look at. You might not be able to really get a lot of information out of that by just looking. You have to run 1 or 2 analysis to bring out useful information in this data. So the first QC, or the first data cleaning technique we'll be looking at, is just to have a general overview on this particular data set. We might just want to look at the columns and see if the column names are tidy. For me, these column names are not tidy, in the sense that we are having revenue in millions, profit in millions, and this could throw an error because there's actually a space in between column names. Okay, most times file names, column names in Python don't actually accept spaces. It could throw you an error, so you have to be very careful with white spaces in file names and column names. So we can just quickly rename these columns, and by saying data frame dot columns, okay, data frame dot columns selects all the columns of our data frame. Let's just press shift enter first. We can see the name of our columns here, right? Year, rank, company, revenue, millions, and that. So we can just rename the columns by saying, let's do rename columns of the data frame. So to rename our columns, we can simply do data frame dot columns. We select all the columns and we assign a new list, right, to the column. So list in Python, create a list in Python by using square brackets. Okay, so here comma rank, my bad, comma company, comma, let's just call this revenue, okay, and comma profit. All right, and shift enter, and there's no error, so we're cool. And we can just quickly check our data frame, maybe the columns, and boom, the columns have been renamed properly to revenue and profit compared to what we have here earlier. Okay, just do Control B to take that out. Okay, so what if we just want to check the first 5 rows of our data set, because you can see our data set is actually very long and you just don't want your notebook to get filled so fast that you now have to scroll and scroll and scroll, hundreds of lines of codes. Okay, so let's just say we want to display the first 5 rows of the data set. There's an inbuilt method in Python called dataframe.add. Okay, so and if we do data frame.add and we do shift enter, that returns the first 5 rows of our data set. You might be curious, why do we have index starting from 0? Indexing in Python starts from 0. Okay, it doesn't start from 1. So 0 is seen as 1, just in that order. So we have 5 rows here. And what if we like, someone would say, oh fine, we can display the head. What about the bottom 5 rows, right? So we can display the last 5 rows of the data set. You will guess, if we have head, we must have a tail, right? So data frame.tail is going to return the last 5 rows of our data set. Okay, and you can see the last 5 rows of our data set according to the index numbers are just this, and that. And alternatively, what if I want to display the first 10 rows of my data set? Maybe I don't need 5, maybe I just need 2, right? Or maybe I just need 4. So let's say display any first n rows of the data set, and let's display the first let's just display the first 3 rows. Let's say the first 3 rows, right? Okay, so it's simple. Since it's the first 3 rows, you would guess that we're still going to use data frame.head because we are looking at the first, okay, first 3 rows starting from index of 0. Okay, and you open your brackets. I will teach you, I want to quickly show you a quick trick to check out documentation for built-in methods in Python. You make sure your cursor is blinking and it's in between the brackets here. So you can simply press Shift Tab, okay, Shift plus Tab key on your keyboard, and boom, you have the documentation for a particular method. Okay, you can see it returns the first n rows, and this function returns the first n rows for the object based on position. Okay, so you would have guessed that if we want to display the first 3 rows of this data set, we just have to pass the parameter 3 right into this bracket, and we can do shift enter to run, and boom, we have our 3 rows being displayed, right? So let's say you want to display the first 4 rows, just change this value to 4 and shift enter, and boom, you have the first 4 rows of your data set being displayed. Okay, another very important concept in data import is sometimes you have a particular data set that has large number of columns, right? And possibly you just don't need some columns. Maybe you just don't want to run some analysis on some particular columns in your data frame, or in your data rather. So there's an inbuilt method in Python that can do that. Okay, and let's just say we want to import data import data using specific columns. Okay, so let's create another variable called data frame.new. Okay, and say pandas, that is pd.read underscore csv, and it's still the same csv file. We want to bring in data slash, I think, for Fortune 500, my bad, Fortune 500.csv. Okay, then comma, there's actually a parameter that the pd.read underscore csv method takes. Is called use columns. Okay, that is use columns. So let's say we just want to import the year, rank, and company columns only. Okay, so we can pass a list and say year, rank, and company. Okay, and if we come to this next line, you come to each next line by pressing enter. Okay, so data frame underscore new, and I do shift enter. You can see, and boom, I have just only the year, rank, and company columns being imported from my data set. Even though in my data set I have 5 columns, now I have just 3 columns. So that's a very, very useful tool in data import. Okay, another quick data wrangling concept I will quickly want to show you is an inbuilt method in Python that is used for descriptive statistics. Sorry, my English is whack. All right, and the inbuilt method is called describe. So we can do data frame.describe. Okay, and if I do shift enter, and we have on our output, we have a quick statistical analysis of our data set, right? The count of our data set, that is the amount of rows we have, the mean per column, okay, the standard deviation, the minimum and the maximum, okay, the 25th, 50th and 75th percentile. Okay, so this is useful for just quick statistical analysis. You just want to look at the minimum and maximum values in your data. You want to see the relationship between the columns of your data set, and you want to see how these values vary or change. Okay, so another very important function built-in method in Python is called the len function. Okay, and the len function is, let's say we use it to check the length of the data frame. So we use what is called the len function, and we can pass our data frame as the argument or the parameter. And if I do shift enter, the length of our data frame is 25,500. Okay, and that's being confirmed by the count, the number of rows we have here. Okay, and another quick QC we can do on the data is to check the data types. Check the data types in each column. Okay, this is very important because you don't want to treat a particular column. Let's say a column is made up of integers, right? And you now check the data type and you are now having strings. You wouldn't want to, you will know there's something wrong with the data type, and you want to correct that before going forward in your analysis. So data wrangling or data processing is very, very important. It's very, very important before you run any algorithm or run any stuff on your data. You must make sure your data is clean enough so that you are not going to have biased results. Okay, so if you remember, we talked about data types some few minutes ago. So there's actually a built-in tool or method that we can quickly use to display the data types we have in our data, and that's you can do that by doing data frame.dtypes. Excuse me, data frame.dtypes. Okay, and on the year column, data type is integer 64. There's integer 8, but that doesn't don't bother yourself about that. Just what you really need to bother yourself about is the data type is an integer. Okay, the rank column, it's also an integer. Company, it's an object. Okay, because like I said earlier, strings are object in Python, and you can say the company, they're made up of string values. Okay, and the revenue column is, let's check, they're actually floats. Okay, revenue are floats. And profit, wow, profit is seen as an object. There's a problem, because our profit column should actually either be an integer or float, because we have numbers here, right? So why are we having our profit column being displayed, the data type of our profit column returning an object? So it means there are some values, right, in our profit column that are strings. Okay, they are not integers, so we have to fish them out, and we have to clean them out of the data so it doesn't affect our analysis. So let's by doing that, let's quickly define a variable called non-numeric profit. Okay, and let's select the profit column, and there's a method called str.contains. Okay, and we can write a regex, okay, a regular expression to contain numbers from 0 to 9, dot hyphen. Okay, I think this should work. And there's a method called dataframe.location, and we can look for the location of this non-numeric profit in our data frame. And let's just display the first 5 rows. Okay, dot head. Okay, this is known as method chaining in Python. Okay, method chaining is a method, and I've changed it. The output of this method is, changed to the dot head method using the dot operator. Okay, so use the dot operator to chain methods in Python. So if we do shift enter, oh, our guess was right. We have some particular values in our profit column as strings. Okay, and that's not NA, maybe not applicable or something. Okay, so what we would like to check again is to check if there are other unique set of values in the profit column. Okay, because we can just only see the first 5 rows of our data here, so it's possible we have some other strings, right, in this particular data set that is not n.a. Okay, so we can just create a set. Okay, create a unique set, okay, of values. Okay, so by doing that, you use the set keyword, okay, in Python to create a set, and we can now pass, the data frame dot profit, and we splice into the non-numeric, non-numeric profits. Okay, and we'll do shift enter. Oh, boom. Luckily for us, it returns a dictionary. Okay, in Python, this is a dictionary. Okay, our dictionaries the notation of dictionaries in Python is using curly braces. Okay, and dictionaries are also objects in Python. Okay, so that's worthy of note. And Luckily for us, our data set has just only one unique set of value, and that's n.a. So we have less number of strings to bother with. And another question we would like to ask ourselves is, okay, fine, I have NA as a unique set of value in my profit column, but I don't know how many of this guy, this NA I have present in the profit column. You would have guessed that to get the number or length of something, we would use the length function, right? Cool. And we can say data frame dot profit. Data frame dot profit. We select the profit column and splice into we select the list non-numeric profits. Okay, and we do shift enter. Okay, we have 369 values, NA values in our profit column. Let me just quickly rename this properly for sake of documentation. So we can say check it's always good to put comment in front of your codes. So when you get back to your notebook, you wouldn't forget what you've done earlier. So it gives you insight and gives you idea of what your workflow is all about. So check the length of the unique set of values. Okay, so we've done that. And another thing we'll quickly want to do is we have 369 NA values in the profit column. Can we quickly get the percentage of NA values in the profit column, to see if we can really drop the number of columns that contains these NA values. Okay, so we can quickly just grab a calculator here. Okay, and we can just do the mathematics. The number of rows we have is 25,500, right? Cool. And do a multiplication by 100%. Oh, we just have about 1.4% of missing values in our data set. It's not too bad. We can overlook that, right? It's not really too bad. So the next thing I would, lest I forget, there's a quick method you can also use in Python, an inbuilt method you can quickly use to return the shape of your data set in rows and columns. That's known as dataframe.shape. Okay, and the output of dataframe.shape gives you row column values, that is like your XY values, 25,500 rows by 5 columns. Okay, so that's also a quick method you can actually use in your data cleaning and data processing. So the next thing we are going to do now is to import our plotting libraries. Okay, because we would still like to visualize this non-numeric profits, right? Because they are actually empty values in our data set, and would also want to visualize how this non-numeric profit is being distributed in our profit column. How the distribution vary with with the year, okay, and with different companies, right? So we'll be able to QC our data properly. So let's import some plotting or import plotting libraries. Okay, the first library we import back then was pandas, so now we're going to import Matplotlib, but first there's a keyword called Matplotlib inline. Okay, this is going to ensure that our plots are generated, very nice in our Jupyter notebook. Okay, and we can now import matplotlib.pyplot as plt. Okay, and another beautiful library I love to use is Seaborn. Okay, import Seaborn as SNS, and we can now do SNS dot set. Sorry for the breaking transmission. There was a bit of distraction. All right, we can do SNS.set. Then we set the style into the dark grid. I prefer to use the dark grid. Okay, and shift enter. Okay, I think we've successfully import all our libraries, and everything is fine. Okay, we're going to quickly take a 1 minute stretch break. Okay, just to stretch our legs and stretch our hands, and take our eyes off the screen for a while. Okay, so in the next 1 to 2 minutes we'll be back. Thank you very much. All right, the break is over. All right, so we successfully import our plotting libraries, and we import matplotlib.pyplot as plt. We try to import Seaborn. Seaborn is a plotting library in Python. It gives us very beautiful plots. Okay, and it's very extensive, and we try to set the style of our plot to the grid of our plot to be dark grid. Okay, so the next thing I would like to do is plot a histogram. Okay, we want to plot an histogram, and the histogram is going to show us the number or the frequency of the non-numeric profits we have in data. So we can just create a variable called bin sizes. Okay, and we'll split our bins. Okay, underscore equals to, we can do plot.hist. That's the keyword to plot the method to plot histograms. Okay, plt, because we've import matplotlib as plt. Okay, if you don't import matplotlib as plt, you would have to always write matplotlib.histogram, and that's a whole hell of work to do. So you just simply say plt.hist and data frame dot, we select the year column. Okay, because we want to see how the non-numeric profits has been distributed or varies along the whole year, or that the distribution of the non-numeric profit in all the years rather. So you have non-numeric profits. Okay, and comma bins. Let's define the bin for our histogram, and takes the range keyword. The range of years should be from 1955 to 2006. Okay, so we've already defined our histogram, right? And then shift enter, and boom. From this histogram, we can quickly visualize that even less than 25 NA values. Okay, we even have the largest amount of NA values around the 90s. It's not even up to 25. So and we can see that in almost from 1955 to 2006, the number reduced, and it has been fairly stable, not except in 1990s, where you just have a lot of NA values. So that shouldn't really give us a lot of headache or a lot of fears about, since we've also calculated that we just have about 1% of missing values in our data set. So we can just move on to convert this non-numeric profits, right, to numeric values, because they are actually objects. The data type is seen as an object, and it's supposed to be a floating type, right? Floating type number. So let's grab our data frame again, and we'll use the data frame.loc. Loc is back. You use loc a lot in pandas. Data frame.location, and we can select, create a list that is non-numeric, that is non-numeric profits. Okay, and let's select the profit column. Data frame.profit is data frame.profit dot use the apply method, okay, and pandas do dot to underscore numeric. Okay, so what PD or pandas dot to underscore numeric does is to convert the string object into its appropriate data type. Okay, so to check, we can now simply check the data type in the profit column, or check the data types, or let's say check the updated data type in the data frame, right? So if you can remember how to check data types, it's simple. Just say data frame.dtypes, right? And boom, our profit column has been updated to be floating type, right? Float. So it's no more an object. So we've corrected that particular error, right? So we can now go ahead to still QC our data by checking the columns of our data. Okay, data frame.columns, and it returns a list, right? It returns a list, and we can see that our columns are correctly named, right? And it returns the data type as an object. All right, so let's quickly let's go deeper into some visualization. Okay, let's from our data set, let's see if we can plot the average profit, by year, to see how profit has changed historically. Let's grab our data frame again, because I'm writing a lot of codes. Oh, sorry. It's going to return. All right. So data frame.head. Okay, this is our data frame, and we would like to see if we could plot the average profit. Okay, let's see how the profit has changed over the years from 1955 to 2006. So the first thing we would like to do is, let me just put a comment. Okay, plot the average. Plot the average I need to go for an English class now. Plot the average profit by year to see how profit has changed historically. Okay, so let's define a variable called group by year and data frame dot look. Okay, select all rows, then comma, then we'll pass a list of the columns we need or want to use, and we need the year column, we need the revenue column, right, and we need the profit column, and there's a method called group by, and we are grouping by the year. Okay, so what this particular block of code or expression is going to do is we're actually passing this into this variable called group underscore by underscore year. Data frame look uses it takes positional, sorry, that's a mistake there. Takes positional arguments, and these are the positional arguments. Okay, so data frame location, this selects all the rows you have in the data set, okay, followed by a comma, and we'll pass the list that check all the rows and the columns. These are the desired columns. We don't need the company, we don't need the rank, and we want to group them by the year. Okay, so what this code is going to do is, for instance, it goes to 1955, okay, and group the revenue and profit for that particular year, okay, and just bring them all together. Okay, and to check that, we can simply say group underscore by year, and it's going to return, you know, something interesting. You see, it creates a pandas.call.group by the generic data frame group by object. Okay, so it means you can now perform statistical analysis because you've grouped your data by the year, and it returns an object. Okay, so another thing we now want to do is, let's create a variable called average, avg, okay, and call the group by year variable, okay, and dot mean returns the mean value, right, dot mean, sorry, okay, and let's create another variable called x, okay, and let's pass the index of the variable avg into x, and let's create another variable y and pass the select avg.profit, okay, the profit column, and would simply define, let's define a function. Let's define a function to plot the average. Let's define a function to plot the average profit per year. Okay, functions are very, very powerful in Python because for those of you that don't know what a function is, functions are reusable block of codes, okay, and functions reduces redundancy in our codes, reduces the time we need to write codes. Okay, so if you write a particular function, you can always call that function anytime you need it, and it makes your life easier. It makes your programming structured, right? Okay, so that you don't have to repeat yourself. There's a core concept in programming called the dry method, that is, do not repeat yourself, don't repeat yourself, right? And functions have always come to the rescue, okay, and we'll see how functions really work now. So to define a function in Python, use the def keyword, okay, the def keyword followed by plot. Okay, plot here is the name of our function. Okay, it could be anything, it could be your name, it could, but just make sure you use variable names and function names that you know are very expressive and defines what you are really doing. Okay, so and functions actually take what is known as parameters, so arguments. So let's pass some arguments into this function, x, y, excuse me, axis, the title, x underscore label, comma y underscore label. Okay, and we have our indentation. So let's set our axis, the axis of our plot. Let's set the title to title, then axis dot set x label, set underscore x label to x label, x underscore label, and axis dot set, excuse me, label y underscore label, and let's plot axis dot plot, actually plotting x against y, right? And scroll up, and axis the margin, let's make our margins tight, x equals to 0 and y equals to 0. Okay, and let's come out of our function and let's define the dimensions of our figure. That's very important. Length against breadth, let's say 9 against 8, right? 9 by 8. And figure comma axis equals to plot, the plot from our Matplotlib, if you remember, plot dot subplots, plot dot subplots, and figure size. Plot dot subplot takes a parameter called figure size, and we can pass it into the variable figure underscore dimensions. Okay, cool. So let's call the plot. To call a function, just write the function name. This is the name of our function, plot. Okay, and we can now pass the parameters we want to plot into our function. So we want to plot x, we'll plot y1, we'll plot our axis, right? And the title, the next parameter in our function here is title. So the title of our plot, let's say increase in mean profit, okay, from increase in mean profit from 1995 to 2006 or 2005 rather, and comma, the next thing is our x label, okay, on our x-axis it should be year, and on our y-axis should be profit, right? Profit in millions. All right, and I think everything should be fine. Let's hit shift enter, and boom, here we have our plot. Okay, so on our plot we can see the title of our plot, increase in mean profit from 1995 to 2005, and on the x-axis we have the year, and on the y-axis the profit, and we have this beautiful plot, you know, being displayed. Remember, SNS.set equals to dark grid. Okay, you can see the grid here is dark. Okay, if we didn't set it, our grid would be white, or if you set it to light, this grid will not be dark. Okay, and you can see from this plot that from 1955 till around 1990, the profits were increasing steadily, right? Has been increasing steadily rather, just a bit of drop, in the mid 1980s, but we have noticeably a very sharp drop, okay, in the mid 90s. And if you are conversant with politics and economics, you will know there was a big recession, in the mid 90s. Okay, and it's seen by this very sharp drop in profits of the Fortune 500 companies. These are top companies in the world. Okay, so it means they didn't really make so much profit, and we could see a very sharp increase, very, 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 very exponential. It's an exponential increase, in profits running close to almost, 1,000 million or 1 billion dollars, like that, in the mid 90s. And this could or would have been at or could have been possible because of the increase in the usage of the internet. The internet started in 1995, okay, and you might want to Google something called the dot-com bubble. Let me see. There's something called the. Oh, I don't have an internet here. Oh, too bad. Okay. You might just want to check out dot-com bubble. Okay. Dot-com bubble was a particular point in time in the tech industry where there was increase in the usage of internet, and the internet just kept sprouting. The internet market was making a lot of profit. The tech world was making a lot of profit rather. So this particular exponential increase might have been attributed to that. And in the mid 2000s, there was also a very serious recession. Okay, and we can see a very sharp drop in profits, and profits, kept increasing again after somewhere close to 2005, 2006. Okay, so that's just an example of how you can just use a simple plot to do a little analysis on price fluctuations, right? And you can see just by defining a particular function in Python, and we're passing parameters, we're able to make this beautiful plot. Okay, so what if let's say we want to generate a plot for the increase in revenue, for instance. This is for profit. So let's say I want to generate a plot for increase in revenue. I think my internet should be back soon. My bad. Okay. Let's generate a plot for increase in revenue. And okay, I think internet is back. So let's check the dot-com bubble. Something called the dot-com bubble. Okay, and you see the dot-com bubble, also known as the dot-com boom, the tech bubble, the internet bubble, was a stock market bubble, okay, caused by excessive speculation of internet-related companies from the mid 90s to about 2004. Okay, and if we come back to our curve, you can see the dot-com bubble was around 1995 to 2004, is somewhere here, and you can see that very sharp increase in profit. Okay, so you might just want to read more about the dot-com bubble. So this is a simple example to tell you that data analysis is real. Data is real. These are real life examples, right? These are not textbook. These are not textbook examples. These are real life data, and real-time analysis, trying to look at real life stuffs, occurrences, and trying to tie it real life events rather, and trying to tie it to a data set. Okay, so we said we would like to generate a plot for increase in revenue. Okay, so we can do y2. Let's say, because we've already declared a variable y1, so let's say we select avg. We've already defined avg. Okay, and average the revenue. Then we can define the axis of our plots plt.subplot and figure size is still equals to figure underscore dimensions. Okay, now see the power of functions. If I call our plot function and I press shift tab, you can see my function is already registered in this particular project workflow, right? Because I've written my Python, I said my Python, sorry, my function, and I can always reuse this function anywhere in my notebook, and I can even import this particular function into another notebook and reuse it. You see, that's the power of functions or methods. Okay, and you can see all the parameters we passed into our function, right? So let's just pass x, right? Pass y2, pass axis, right? The next thing should be title, right? So the title of our plot is increase in mean, increase in mean revenue per year, right? Because we're trying to look at the revenue. X label should be year and Y label should be revenue, right? Revenue in millions. Cool. Okay, shift enter, let's see, and boom, our plot is here. Okay, we can see that from this plot, from 1955 to about 2005 thereabout, the revenue has been increasing steadily, and even during the dot-com bubble, you can see in 95 the revenue skyrocket. You can see you have that exponential increase in your revenue. So that's to tell you a lot of sales was generated, according to, if you see from our Wikipedia text here, the stock market, you can see there was an increase in revenue in the stock market for most of the Fortune 500 companies, and you can see that exponential growth, at this particular part of the curve. From 55 to about 95 thereabout, the growth has been kind of steady. Okay, even though the growth from 55 to somewhere around 1970 has been sluggish, okay, you're almost having a flat line, right? But the growth has just been a bit redundant until it picked up around the 90s, and the breakthrough came in 95, okay, where you had the exponential growth. So I think we should say kudos to the sales team in that particular year, because they generated a lot of revenue. That must have been a lot of work anyways. Okay, so we can still want to ask ourselves, some basic questions as regards this particular data set. Okay, and like I said earlier, data science is subjective. What I mean by subjective is it depends on what you want to bring out of the data. It's subjective in the sense that the questions I might like to ask, or the questions I would like or the responses or what I would love to see in my data might be different from what the inference you would like to draw from the data, right? So this particular data set, we can ask ourselves tons of questions, right? We can get tons of insight from just this Fortune 500 data set. And let's just ask ourselves some basic questions. Like, oh, my bad, sorry. We might want to check, for instance, what is the maximum profit? This is simple questions, right? What's the maximum profit? What is the minimum? Oh my bad. Minimum profit, right? Made by these companies. Which company made the highest revenue and profit? Okay, these are just basic questions. What if we want to, let's say, how has the profit and revenue changed historically? These are just data analytics questions that you just want to get insights from the data. So let's tackle these questions one by one. What is the maximum profit? So let's define a variable called max profit. Okay, max profit, and we can select the profit column because that's what we're interested in, right? So data frame.profit, and there's a max method, okay, in Python, and we can also say max underscore rev. Let's just say max underscore revenue. Yes, data frame dot, as you would have guessed, we'll select the revenue column, right? The revenue column dot max, because we are still looking for the maximum. Okay, so let's just change this to what's the maximum profit and revenue, right? And what's the minimum profit and minimum revenue. Cool. All right, so data frame dot that. So we might just want to print our output and make it more human readable and say the max profit is okay, comma max underscore profit, as you would have guessed, and that will be in millions, right? Okay, these are all string formatters, and comma, and let's insert a new line, \n, okay, and say the max revenue is then comma, and we take max underscore, excuse me please, max underscore revenue, okay, and comma that comes in millions too, right? Million. Okay, and if I do shift enter, boom, we have the maximum profit to be 25,330 million, and the maximum revenue is 288,189 million. Okay, now we have our maximum profit, we have our maximum revenue, right, from this data set, but we don't actually know the company that made this huge amount of profit, right? So the question we might want to ask ourselves is which company made the maximum profit, right? So data frame.log is back. Okay, that's one of my favorites, comes to the rescue. So we splice into we select the data frame.profit column, and you remember that we're trying to compare, and The maximum profit is 25,330. So we just pass, that figure there, and we do shift enter, and boom, the company with the maximum profit from the Fortune 500 data set is ExxonMobil. Okay, and we might also want to ask ourselves, or let's do this as an exercise. Okay, you might just want to grab your notebook and do this as an exercise. Which company made the maximum revenue? Okay, so let me just give you a tip. Simple. Okay, just the same way we did for the profit. The tip is use look. Okay, that's the tip, and pass the value. The maximum revenue we have is 288,189. Sorry, 288,189. Okay, so use look and pass the value this into, okay, and compare. I think I'm already giving you guys the answer already. So just use log, okay, and just pass dataframe.revenue, okay, dataframe.revenue column, and you pass the value into 28, or you compare the value with 28 to 288, 189 million, okay, and so you just do that as an exercise in just 1 minute, and let me know what your answer is. Okay, I guess that shouldn't take you more than 5 seconds. So which company made the maximum revenue? So this is the solution. That will be dataframe.log. So like I said, you look at you select the revenue column, okay, and our revenue is 288,189, okay, and boom, the company is Walmart stores, okay. So Walmart stores had made the highest revenue, okay. Now before we round up today's session, let's just ask ourselves one or two more insights or questions into this data set. Let's say we want to explore, okay, let's say we want to explore how revenue and profits has changed, okay, historically for just one company, okay. Let's say we just want to run an analysis on, let's use ExxonMobil for instance, okay, and we just want to grab ExxonMobil in this data, grab every rows that have ExxonMobil in this data, and run a quick analysis to see how the revenue and profit has changed for just ExxonMobil only, right? So we can say data.exxon, okay, so, and dataframe.log, okay, location, and as you would have guessed, we'll look into the company column, okay. Company equals to ExxonMobil is a string, so ExxonMobil, okay, and next we can do data underscore exxon.shape, okay, no, .ed, okay, and Oh, we're not returning anything. There must be a problem somewhere. Um, Something is wrong somewhere. Um, let's check our columns properly. Column names might be wrong with the column names. Okay. Company. Okay. Data frame dot company. Okay. Exxon Mobil. Oh, that's where I made a mistake. So it should be capital M. Okay. Cool. All right. Cool. We have it here. So let me just delete this. Okay. Double D. All right. Cool. So in our data frame .head, this is the first 5 rows of our data frame where the company name is equals to ExxonMobil. So what this code does is to select the company column, okay, select the rows or select the company where the company name is equals to ExxonMobil, okay, and return, the rows, or return the rows where the company name is equals to ExxonMobil. So ExxonMobil is the keyword here, so everything you have here, the company is just only for ExxonMobil. So we can simply you do our group by year, okay, because let's do our group by year and say data underscore exxon dot loc. Okay, well, we used to loc a lot today. We have to pay loc royalties, right? All right, so thanks to whoever created loc. It's very powerful. So revenue, as you would guess, we'll pick the profit columns and we'll group by the year. Group by year, my bad. Group by the year. Okay, and let's define AVG again and say group by year, the mean value. Okay, and let's define X as we've written something like this earlier. If you can remember, we wrote something like this earlier rather. So this shouldn't be too strange at the moment. Average profit. So we could quickly write a function to plot the average profit by year. So what I would just like to do, it's not advisable to copy and paste your codes, but to save time, this same function, I'm just going to copy this. Okay, I'm going to copy this, Control C. Okay, and just bring it down here and paste. Okay, to save some time. Okay, and I don't want the margins to be tight. Okay, and the title of my plot would actually be increase in mean profit. Okay, because we are looking at just one company, right? For ExxonMobil from 1995 to 2005 and profits in millions. So I think everything is fine, and if I do a shift enter, boom, we have our plot. Not that too bad for ExxonMobil, but you can see there was an exponential increase at the end of the 90s, okay, close to the millennium, year 2000. There was an increase in profit for ExxonMobil, and also mid 2000s there was a sharp drop from the early 2000s, and there was also an increase, okay, from the mid 2000s or early 2000s rather, okay, and if I'm quite correct, the oil price at this, because this is an US based oil company, ExxonMobil is a US based oil company. So the oil price around the early 2000s were fairly high, okay, and you could see that the ExxonMobil Corporation made a lot of profit. Here, the profits were staggering, okay, staggered profit here and there, and it's just fairly the same, just no serious visible changes, and it was quite steady, in 1955 to the mid 70s, okay, but you can see that exponential increase in profits in the year 2000. So this having little interactive plots like this can give you insights into the data. You can just decide to pick. We have different companies here. You can decide to pick for Walmart stores and look at how their profit has changed over the years, right? Okay, and we might also want to, as an exercise, we've displayed, or we generated a plot for increase in mean profit for ExxonMobil from 1995 to 2005. So as an exercise, I would like you to generate an exercise. Oh my bad. Exercise. As an exercise, I want you to generate the increase in mean revenue, okay, for ExxonMobil. So to do this, it's very simple. We already have our function here, okay, so just call on the function. The figure underscore dimensions is okay. You might want to increase the dimension of your figure. It's your choice depending on what you like. If you like your figures to be very big or to be small, it depends on you, okay. And just be sure to select your X and Y2, especially your Y2 by the revenue column, not the profit column, okay. And I guess that should be very simple to do. So one of the last questions we would want to ask ourselves, as regards the ExxonMobil company is, let's say for instance, we can continue asking a lot of questions, right? But let's just stop here because of time. So we can say, in what year did ExxonMobil had the lowest profit, right? Because we're just looking at ExxonMobil only, so we want to know the year they had the lowest profit. So the name of our data is data underscore Exxon, if I'm still correct, dot head. Okay, just to bring back our data. Okay, this is how our data looks like. So we want to know the particular year in which ExxonMobil had the lowest profit. Okay, so you would have guessed that we would have to select the ExxonMobil profit column, right, and use the minimum method, the mean. Okay, and the minimum profit for ExxonMobil was 562.5 million, right? All right, so to know the particular year in which the profit was minimum, this particular profit was generated, we can just do data underscore Exxon, right? And our dear Luke is back again. And data underscore Exxon, right, dot the profit column, okay, as you would have guessed, where it is equals to 562.5, right, and shift enter, and boom, in the year 1959 ExxonMobil made the minimum profit, which is 562.5. Okay, so the last exercise or take-home assignment for the day is generate, or we might simply say in what year did ExxonMobil had the highest profit, or the maximum profit, right? The maximum profit. So this is very simple. Okay, just use the profit dot max. Okay, the max method. Okay, so that's going to be, first of all, get the number. Okay, data underscore exxon dot profit dot max. Okay, and you can use some loc, right, to display the particular role in your data set that has, the maximum value. So I would like to stop here for today. Our time is far spent, and I hope it has been an exciting time with you on this webinar, and I hope you've been able to grab one or two concepts, okay, from understanding data types in Python, and we tried to do a bit of data cleaning, a bit of some processing, okay, and then we tried to generate some beautiful plots, and we also try to ask ourselves, some basic statistical questions and analytics questions to get insights, about how values have changed in our data set, and how various events, have contributed to, the values we have in our data set. So to me, it's been